Today I want to talk to you about something called concentration. Now, concentration, if I want to define it, is the ratio of solute to solvent in a solution. Basically, how much solute I have dissolved in the solution based on how much solvent I have. We've already sort of talked about this when we talked about concentrated versus dilute. If something is more concentrated or more dilute, it means it's got more solute or less solute dissolved in it. That's what concentration is. Let me give you a few more examples. So I have here 4 test tubes. Now, all 4 of these test tubes have the exact same thing in them. They all have copper 2 sulfate dissolved in water. Now, the difference between these 4 test tubes is actually concentration. All 4 of these test tubes have a different amount of solute in them, the copper sulfate, versus how much water it has. So this is actually the most concentrated, and then this is the least concentrated or the most dilute. So this one's very dilute, this one is very concentrated, and it's a spectrum going from here to here. So this one is actually more concentrated than these two, but more dilute than this one. All right? Now, all 4 of these, I want to point out, are unsaturated. All 4 of them could have more copper sulfate dissolved in them, and I could actually get more dissolved in this one here, the most concentrated one, and get it to be even darker before it actually became saturated. So just to be clear, they're all unsaturated because I could get more to dissolve in them. But this is the most concentrated, this is the most dilute, and it goes in order. Now what I want to point out here is if I add, I'm going to put another one here. Now if you take a look at this one is actually darker than this and darker than this. So if I were to actually put them in order here, right there, it actually matches the same color as this one right here. So this one is actually the same concentration as this one here, but there's less in it. So what that means is that there's actually the same ratio of solute to solvent. However, it has both less solute and less solvent in it. It's the same ratio though. Basically, I have the exact same concentration in both of these, but I didn't use as much of either solute or solvent. Okay, so here's a simulation to show the molecules of what's going on when something is concentrated versus dilute. So what I'm going to do is I'm going to dissolve some salt in this water here. As you can see, as it goes in the water and it dissolves, the sodium ions and the chloride ions actually break apart from each other. And they're floating around separate in the water. They're interacting with the water molecules. Now, if I were to actually add more salt to it, this salt also dissolves, and this makes it more concentrated. So the concentration here has gone up, so it's more concentrated, and there's a way to actually measure the concentration based on how much of the sodium chloride ions are actually dissolved. You can measure it. You can also measure how much water there is and compare the solute and the solvent. Now, if I were to add more water to this is actually diluting it, watering it down, so the concentration is now less. Less concentrated means that I have more solvent per solute, per salt that's dissolved in there. Now, concentration can actually be calculated. It is a measurement. So what we do is we take the moles of solute that we dissolve in it and we divide it by the liters of solution that we make from it. And this is something called molarity. This is actually a unit, capital M for molarity. This is a measure of how much solute we have per solution, and it's calculated. We have to measure the moles of solute that we're dissolving and how many liters of solution we actually dissolve it in, and we can calculate the molarity. Okay, so in the lab, a student adds 4.5 grams of sodium chloride, which is salt, to water to make 100.0 milliliters of solution. Calculate the molarity or the concentration of this solution. So, to start off, the molarity is equal to the moles of solute divided by liters of solution. Okay, that's how we're going to calculate it. So I need to find moles of solute and liters of solution, neither of which were given to me by the equation. So first off, start with the moles of solute. So I'm given 4.5 grams of sodium chloride. The formula for that is NaCl, positive 1, negative 1, so it's 1-to-1 ratio. And then I'm going to convert that to moles. So 1 mole on top, and it's 58.44 grams per mole. I used the periodic table to calculate that, and I add together the molar mass of sodium and chlorine to get my answer there for the molar mass. Grams cancel. 4.5 times 1 divided by 58.44 is 0.077002053 moles. So I have moles of solute that I'm dissolving. Next, I need to figure out my liters of solution. Well, I've got 100 milliliters, so I just got to convert from milliliters into liters. So I've got 100.0 milliliters, and there are 1,000 milliliters in 1 liter. So that's 100 times 1 over 1,000 here. That's going to give me 0.1000 liters of solution. So now all I've got to do is take these two numbers and plug them in here. So I've got my moles of solute is 0.0770 blah, 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 blah moles divided by liters of solution, 0.1000 liters. So I take my 0.07700200534, divided by 0.1000, and I get 0.77002. It basically just moves over a decimal place. Now, significant figures here. I used this number and this number. This has 2 and this has 4, so my lowest is 2 here. So I'm going to round this answer to 0.77, and that's it. Capital M for molarity. There's my final answer. That's the concentration of the sodium chloride in this solution. Here's another example. What is the molarity of a solution made by dissolving 6.75 grams of potassium nitrate in water to make a solution with a total volume of 452 milliliters? Once again, concentration, molarity, is equal to moles of solute divided by liters of solution. I don't have either of those, so I'm going to take and figure out first the moles of solute. I've got 6.75 grams of potassium nitrate. Formula is KNO3. Nitrate is a -1, potassium is a +1, so that's a 1-to-1 ratio again. I'm going to times it by its molar mass. So 1 mole on top, and the molar mass of potassium nitrate is 101.108 grams per mole. Grams cancel, so I've got 6.75 times 1 divided by 101.108 gives me that answer right there, 0.06676, so on and so forth, moles of potassium nitrate. Next, I need my liters of solution. I've got 452 milliliters, so I just got to convert that to liters. 452 milliliters. There are 1,000 milliliters in 1 liter, so 1 over 1,000. That cancels the milliliters. That gets me 0.452 liters here. So now that I've got both pieces, plug them into the equation here. 0.06676, so on and so forth, moles divided by 0.452 liters. That gets me molarity. So take my answer there, the fully unrounded one, divided by 0.452, and I get 0.147699967, so on and so forth. Significant figures here. I've got 3 in that one. I've got 3 in that one, so I'm going to round this answer so it only has 3. So 0.14, and then the 7 I keep, but since the next digit's a 6, I'm going to round that up to 8. Molarity. So the answer for concentration for this one is 0.148 molar or 0.148 molarity. Okay, so in this last example, something a little different is going on. At 20 degrees Celsius, a saturated solution of calcium sulfate, CaSO4, has a concentration of 0.0153 molarity. A student takes 65 milliliters of this solution and evaporates it. What mass in grams is left in the evaporating dish? So this is actually not asking us about the concentration. It actually gives us the concentration, and what it asks for is how much of the calcium sulfate in grams is actually in that solution if I have 65 milliliters of it. So this is basically working backwards. So I'm going to write out the equation here just so you can see how this works. Concentration molarity is equal to moles of solute divided by liters of solution. Now I'm given the concentration and I'm given how much solution I have, even though it's not in liters, it's in milliliters. What I don't know is how much solute I have. So there are 3 parts to this equation, and I know 2 of them, and I'm only missing this one right up here. So what I'm going to do, first off, I'm going to convert the 65 milliliters into liters. So there are 1,000 milliliters in 1 liter. Milliliters on bottom, so it cancels. That gets me 0.065 liters is actually how much I have of this solution. And now what I'm going to do is I'm going to plug everything I know into this equation, and the one thing I don't is what I'm going to find. So I do know the molality, so I'm going to plug that in down here. I know the molarity is 0.0153, and it's equal to the moles of solute. I don't know that, so I'm just going to leave that as an x, divided by the liters of solution, which in liters is 0.065 liters. Okay, so now that this is the only thing I don't know, find x. I'm going to times both sides by 0.065 liters, so this side cancels. And over on this side, times it by 0.065 liters. So x here is the only thing that's left, is going to be equal to 0.065 times 0.0153. And that is actually equal to 9.945 times 10 to the power of negative 4. Moles. Now, why am I not rounding this? It's because I'm actually not done with the problem. If you look up here, it asks for mass, not moles. So I actually have, my last step here is to convert these moles into how many grams it is. So I'm going to take this answer here, 9.945 times 10 to the power of negative 4 moles, times it by a ratio. 1 mole on the bottom this time, so it cancels, and then I need the molar mass of the calcium sulfate, CaSO4, on top. So grab a periodic table, and the molar mass is 136.148 grams per mole. So I'm going to take the 9.945 times 10 to the power of negative 4 and times that by 136.148 over 1. And that gets me a mass of 0.135399186. This is where I round for significant figures. So the numbers that I actually used, my starting numbers here, were 65 and 0.0153. So this has 3 sig figs, this has 2 sig figs, so I'm going to round it to the lower of those 2 significant figures. So I'm going to round this to 0.13, but then the 5 rounds it up to 4. So 0.14 grams of the calcium sulfate is how much I would have left after all the water evaporated.